Ahoy to fellow seafarers! Welcome back to the channel that navigates you through the seas of maritime knowledge. Today, we're learning how to solve the amplitude of the sun for both sunrise, east, and sunset, west, to help you check your compass error and gyro error. This is one of the most practical celestial navigation methods still in use today, especially when electronics fail. It's also one of the best ways to check the accuracy of your gyro compass. Ready? Let's set sail. In celestial navigation, amplitude is the angle along the horizon between true east or west and the point where the sun rises or sets. If the sun is rising, it's called amplitude east. If it's setting, it's called amplitude west. It's also labeled north or south, depending on the sun's declination. By calculating the sun's amplitude, we can determine its true bearing at that moment, then compare it to the gyro or compass bearing you observe. The difference is your gyro error or compass error. To solve for amplitude, you'll need 1. Latitude of your vessel. 2. Declination of the sun. From the Nautical Almanac. 3. The observed gyro or compass bearing of the sun when it touches the horizon. We'll use all of these to find the true bearing of the sun and compute your gyro error. The basic formula is sine amplitude equals sine declination of the sun divided by cosine latitude. Make sure both declination and latitude are positive if in the same hemisphere, NN or SS, and negative if opposite. You will use a scientific calculator or mobile app to solve the arcsine inverse sine to get the amplitude in degrees. Once you calculate the amplitude, use it to find the true bearing of the sun. Then compare that with your gyro or compass bearing to find the error. Let's try a sunrise example. Latitude, 10 degrees north. Declination, 23.1 degrees north. Gyro bearing of the sun, 65 degrees. Step 1. Plug into the formula. Sine amplitude equals sine declination of the sun divided by cosine latitude. Sine amplitude equals sine 23.1 degrees, declination of sun, divided by cosine latitude 10 degrees. The result or amplitude equals 0.3983. And by pressing the inverse sign on your calculator, it will show the final amplitude equals 23.5 degrees. So, amplitude equals n 23.5 degrees east. The amplitude of the sun is named the same as the declination and is denoted as E or W, depending on whether the sun is rising or setting. Step 2. Compute true bearing at sunrise. 0.90 degrees minus 23.5 degrees equals 66.5 degrees. True. Step 3. Compute the gyro error by comparing the observed gyro bearing to the true bearing. The true bearing equals 66.5 degrees, and the gyro bearing equals 65 degrees. So, gyro error result will be equals 66.5 degrees minus 65 degrees. Equals plus 1.5 degrees east. We determine the error's name using this rule: gyro best, error west; gyro least, error east. Since the gyro is less than the true bearing, the gyro error is 1.5 degrees east. Now let's try a sunset example. Latitude, 20 degrees north. Declination, 23.5 degrees north. Observed gyro bearing of the sun, 296 degrees. Step 1. Plug into the formula. Sine amplitude equals sine declination of the sun divided by cosine latitude. So, sine amplitude equals sine 23.5 degrees divided by cosine 20 degrees equals 0.3987. Divided by 0.9397 equals 0.4243. The amplitude equals inverse or shift sign, depending on the setup of your scientific calculator, or arcsine 0.4243 equals 25.1 degrees. So, amplitude equals n 25.1 degrees west. Step 2. Compute true bearing. 270 degrees plus 25.1 degrees equals 295.1 degrees true bearing. Step 3. Compare to gyro bearing. True bearing equals 295.1 degrees, while the gyro bearing equals 296.0 degrees. So the gyro error will be equals 295.1 degrees minus 296 degrees equals negative 0.9 degrees west. Apply the rule: gyro or compass best, error west; gyro or compass least, error east. If your gyro or compass reading is higher than the true bearing, the error is to the west. If it's lower than the true bearing, the error is to the east. Since the gyro bearing is less than the true, the gyro error is negative 0.9 degrees west. To summarize, use the sun's amplitude at sunrise or sunset. Apply the formula using your latitude and the sun's declination. Get the true bearing, then compare with your gyro or compass bearing. The difference is your gyro error or compass error. Pro tip: make sure the bearing is taken when the sun just touches the horizon. No higher, no lower. Accuracy depends on proper timing and a stable gyro. This is a tried and tested method, still taught in maritime schools, and still relevant for safe navigation. Thanks for joining us on board today. If you learned something useful, leave a comment. Don't forget to like, subscribe, and follow for more practical shipboard tutorials. Until next time, stay sharp and sail safe, fellow seafarer.